Hi, welcome back to the channel, and today we're going to talk about quadratics. Yes, the famous quadratics, and you've probably heard about these in some different contexts with equations, with functions. We're going to get into functions in another video, but this video is basically just introduction to what quadratics are and how to solve a quadratic equation, okay? So let's begin with what do we mean by a quadratic expression? Let's begin with expression. A quadratic expression is a mathematical sentence that has some variable to the power of 2. So an example could be x squared plus 3x. See, this is a quadratic expression because numbers multiplied by each other, there are two terms being added, and you have some variable to the power of 2. This is the important part that makes this a quadratic, okay? Now, let's say instead of giving you this without an equal sign, which is why it's an expression that doesn't have an equal sign, instead I wrote x squared plus 3x equals 0. Now, this becomes an equation, since we have some expression here equals to 0, in this case. And in an equation, for us to recall, we made a series of videos about that. We have our variables have specific values, and usually if you're given an equation, you're supposed to find the value of that unknown. So let's try to solve for x in this equation, correct? Going back to how to solve equations, we want to isolate the variable in one side, right? That's how you get the value for x. And here, well, if you look at this, there really isn't much how you can isolate the x. If you subtract the 3x from both sides and send it to this side, you would end up with an x on both sides, which is not very helpful. And then, well, you may ask me then, how do we solve for the value of x? And for these types of problems, mathematicians actually figured out this kind of trick that has to do with factoring that we went over in our last video. And well, I'm going to show you how factoring works in this case, and then why it works to solve for x, okay? So what if we were to factor this? Well, in this case, we can do the very simple, breaking down each of these into multiplications. 3 times x. This is what we went over in the video about factoring. And here we can do the undistributive property, the opposite distributive property, with x. Since x is being multiplied in both of these numbers, we can pull our x out and make x times x plus 3, right? Because it's the same thing. If we multiply back, we get x squared plus 3x, okay? So we're just rewriting it as in a factored form, where we have things multiplied by each other. And let's return to our equals 0 so we don't forget this is an equation, right? Now we look at this, and you may ask, well, why is this so useful for us to solve for x? And first, to get to that, we have to recall a very important principle of mathematics, which is that anything multiplied by 0 equals 0, right? If you had a very big expression times y times whatever, all this stuff multiplied by each other, multiplied, not added. If you had anything multiplied by anything that had also multiplied by 0 inside of it, everything automatically equals 0, correct? No matter what you have here, if it's multiplied by 0, you still get a 0. And so we can look at this equation and go back to, well, what do we want to do in our equation? We want to find the values of x, of our unknown, that make this equation true. And in this case, what values of x can make this side equal 0? Well, first we can say, well, since x is being multiplied by this, if x was 0, then the whole equation, this side of the equation, would also become 0, wouldn't it? Because 0 times this, independent of what it is inside of this, would just become 0, right? And this way, we have one of the solutions of our equation. Because if you plug in x, 0 instead of x, and you could even plug it in here as well, but it wouldn't matter. Whatever's in here, since everything is being multiplied by 0, just equals 0. So one of your solutions to this equation is x equals 0. And we're going to show how to check that later. Now, okay, we found one way to make this equation, to make this side equal 0. Now, is there another way that we can make all of this equal 0? Well, what if we look at what's inside of this parenthesis? If whatever is inside of this parenthesis was 0, wouldn't everything become 0 the same way? Imagine if instead of x plus 3 you had a 0, you would have 0 times x, which would equal 0. Yes, correct. So now we want to find whatever, what value of x would make this parenthesis equal to 0. And then we can bring that over here. X plus 3, we can even make that an equation, but you probably know what it is just by looking. X plus 3 equals 0, x has to be negative 3, right? And we can do the opposite operations, would work the same way. X equals negative 3. And that is our second solution. Okay? And, well, let's first check that now to make sure we didn't make any mistakes and see what we actually mean by this. Okay, so if we plug in 0 in our initial equation, let's bring that over here. If we plug 0 in, instead of x, we would have 0. I'm going to put in parentheses just to be very clear. 0 squared plus 3 times 0 equals 0. Is this true? Well, 0 to the power of 2 is just 0. 3 times 0 is 0, so 0 plus 0 equals 0. Yes, so we've shown that when x equals 0, this equation is true. Now let's check it for our second value. Oh, and let me make it very clear. When x equals 0, this happens. Now when x equals negative 3, let's see what happens. We have negative 3 squared plus 3 times negative 3 equals 0, right? Now let's evaluate this to see if this is true. Negative 3 squared is the same thing as negative 3 times negative 3, and important to note, negative times negative equals a positive, so this will equal 9, right? And 3 times negative 3 is negative 9, so plus negative 9 equals 0. 9 plus negative 9 is the same thing as 9 minus 9, which also equals 0. So our equation is true when x equals negative 3. And this is just to show you why this process works. And also, it's important to keep in mind that when you're solving a quadratic equation, you will usually have two answers, two final answers, two solutions for x, okay? Different from a normal equation where you usually have just one, right? But this was a more simple example of a quadratic where you could just factor by doing this opposite distributive property. There will be more complicated types of quadratics where you can't just do this, but we'll go over those strategies for those types of quadratics in the next videos. But the underlying concept is that when you're solving for quadratics, you want to break this addition that you usually have into things that are multiplied by each other, into pieces that are multiplied by each other, and then check what values of x would make each of the pieces 0. Because when this piece is 0, everything is 0, so the equation is true. When this piece is 0, everything is 0, so this equation is true, okay? And we'll go through that with more examples in the further videos. And yes, that is it. If you have any other questions, you can email us, leave them in the comments. Thank you for watching.